This is a demonstration for the classification of signals program. So first we will have the continuous and discrete. We will input a value for period, which is 10, and an amplitude of 3. Then we will select continuous time signal, and it will plot a continuous sine wave. And for its discrete format, it will look like this. This is a discrete time signal with amplitude 3 and period of 10. Then for the deterministic signal, we will have defined with equation and a non-deterministic signal, which is a random signal. And for even signals, we will have these three signals, which is symmetrical to the y-axis, and odd signals, which are symmetrical to the x-axis. Next, we will have periodic signal, and this time we will give a value for our period 5 and amplitude of 10. This is our periodic signal. And a non-periodic signal is just the same with a random signal. Next, we will have a real signal, and the given equation is e raised to j 10x. First, we will plot the real part, which look like this, and an imaginary part that looks like this. Next is the energy and power signal. So we will first calculate the time-scaled energy signal, which is a value of scaling factor equal to 4, and we will give an energy of signal equal to 1, and then we will have a time scaled value equal to 0.25. So let's say our given energy signal is this, and since for an energy signal the power is automatically 0 for an energy signal. For our callbacks, let's separate these into 6 panels. First, we will have continuous and discrete. The only callback here is for the push button plot and the slider for period and amplitude. The callback for the slider of period is this. So this variable will get the handle for the slider num. The slider num tag is this slider, and after that it will set the handles of the period. So the tag of the period is here. So whatever the value of the slider num, it will set the value to the period. It is also the same with this slider. The only difference is the variable amplitude and slider num 2. And for the plot, first we will label the period and amplitude. It will get the handles from our static text with the tags period and amplitude. So also it will get the handles of the radio button, which have the tags of continuous and discrete. So if B equals 1, or the radio button labeled continuous is equal to 1, it will plot a simple sine wave using the value of the amplitude and the period. And if B2 is equal to 1, this is the discrete radio button. It will plot the same sine wave, but instead I use the stem syntax. For the next is the deterministic and non-deterministic. So this is the only callback. We have the variables for the value of the radio button, deterministic tag, and non-deterministic. So if the deterministic is selected, it will just plot a normal cosine wave. It is defined with this equation. And if the non-deterministic is selected, it will generate a random signal using the syntax rand. Next, we have the even and odd signals. So it will again get the value of this radio button, either 1 or 0. And if even signal is selected, it will plot these three signals, which are all even signals. And if odd is selected, it will plot these two signals, which are all odd signals. Next, we will have periodic and non-periodic. So I use the same slider and static text here, and for the callback of the plot, again it will get the values of the radio button and period and amplitude. And the callback for periodic is the same with continuous, and the callback for non-periodic is the same with a non-deterministic signal, which is a random signal. Next, we will have a real signal, and I use the given e raised to j 10x. So I use this x equals to the equation, and I just label a as the real x and b for the imaginary part of x. And then if real is selected, it will plot the real value of x, and for imaginary, it will plot the imaginary value of x. Next, we will have the energy and power signal, and again this is a slider button for the energy, the static text, and for calculation, this is just to calculate the time scaled energy signal, and I use the formula for energy over A, and the A is given, which is 4 from x of 4t, and it will set the answer to the static text. After that, it will plot. The H here is for the energy signal, which will plot a triangular signal, This is the given for an energy signal, and I is the power signal, and because this is an energy signal, the power is just equivalent to 0.